Hello again, Tom from Every Step Physics, everystepcalculus.com. It's a quick one problem here on physics. I want to kind of get a couple here for centripetal acceleration and other variables, and maybe help you on your homework or whatever you might need here on the internet, whatever. This was sent in by some kid, asking a question, showing him how it works. So let's do it. Again, we have the radius of 2.5 meters, which we put over on the side. R equals 2.5 meters, and we have the frequency F equals 0.02 cycles, hertz. So we put that on the side, and then we look for what's asked for. And what is the centripetal acceleration? Okay, so that clues you in that you want to go to my menu in physics for centripetal acceleration. That would be in the C section. So let's go down here. It's going to be a quick video here. Center of mass. There's centripetal acceleration. And we're looking for radius and frequency, so we want number 2. And we enter the variables alpha 2.5. And it's meters, number 3. And the frequency is alpha 0.02. And I'll show you what you've entered. Looks pretty good. These are all pretty easy problems if you know the answers, and the tricks to it. But when you've got 20 problems on a test, you might not be fully aware of this stuff, and you'd like to get a few of these right, since it's scored on class curve and partial credit for each problem, and of course the more points you get, the better your grade is and the better you get in the class. So anyways, here's time. Time is 1 over the frequency. 1 over 0.02 is 50 seconds. Okay, we're looking for the velocity. Velocity is 2 pi r divided by the time. Here's 2 times pi times the radius divided by the time, 50 seconds. Turns out to be 15.7 divided by 50 and 0.31416 meters per second. Notice that's pi. And so the centripetal acceleration is v squared over r. So we have 0.31416 squared over 2.5, turns out to be 0.03948 meters per second squared. Pretty neat, huh? Go to my site, buy my programs, and pass physics. Simple as that. They're genius programs, and ready to go for you. Okay, so have a good one.